This is a competition sponsored by NASA and America Makes, focused on designing and fabricating habitats for human colonies on Mars in the year 2035. The design for our entry started by thinking about how Martian conditions differ from those on Earth. And we tried to come up with material and fabrication strategies and structural strategies that could respond to those needs. We noticed that there was a lot of silica in the soil in many parts of Mars. And we also noticed that the atmospheric composition and the soil composition contained the necessary compounds to make thermoplastics, which we could use to create an airtight membrane to contain the pressurization inside of our structure. It starts out as a woven fabric that is then heated to create a very strong, very lightweight, airtight, and easily obtained material. So our additive manufacturing strategy, which was one of the themes of the competition, was to take these materials, this thermoplastic and the fiberglass, as filaments, which we would weave on Mars, into a tubular fabric using an additive manufacturing weaving loom.
I think the amazing thing about this project is that we were able to go from an architectural concept and not be bounded by existing technologies which would inform our design. We worked saying what are the kind of constraints and conditions that we're responding to, what type of architecture is appropriate to it, and then working backwards and saying we can actually create our own fabrication technology and actually mock it up and test it here at MIT.
We didn't use a conventional 3D printing approach to make our model, or at least we didn't exclusively use conventional 3D printing.
We used some new techniques, new to us. Casting aluminum was something we've done for the first time this summer in a little outdoor foundry that we've set up outside our shop in N51. So casting aluminum tooling and then machining it and using that, sort of making a tool to make a tool to make the final part that we're interested in, was a little bit of a new process for us compared with what we've done in the past. And it was exciting to be able to work with students from all different departments across campus, as well as to get some of our students in our undergrad and master's programs a lot more hands-on experience than they would have gotten otherwise.
The range of students that we had really contributed to the success and richness of the project. We had undergraduates, we had graduate students, and we also had people from many different departments. We're based in architecture, and this was primarily an architectural competition, but contributions from students in computer science, mechanical engineering, civil engineering, computation, really helped to enliven the process of design, to help us understand diverse perspectives and gain deeper knowledge in areas that we didn't already know about, and also helped to improve the design itself. So the design really benefits from strong technical backgrounds from a variety of people from a variety of fields. As our collaboration progressed, we became more excited about discovering new ideas and answering the questions that we had set out for ourselves than merely entering the competition and producing a winning design that looks nice. We really got into the deeper questions about where science and technology meet, and the lessons that we learned and the questions that we started to open up will continue to inform us, I think, for a long time after this competition, regardless of what happens in terms of the judging.